Hi, this is Chen with UC Cooperative Extension. Today I'm going to teach you how to do stem water potential measurements in a vineyard. There are two kinds of water potential measurements we typically do in vineyards: leaf water potential and stem water potential. Leaf water potential is very common, but doesn't account for the variation in leaves that you find in a real vineyard. As you can see, some leaves are a little bit bigger, some a little smaller, some a little lighter in color, and some a little darker green. And that all adds to variation in the water potential measurement that we get. The other kind of measurement is the stem water potential measurement, which uses these mylar reflective bags with a little zip at the top in order to reduce the effect of leaf variation on our water potential measurement. Water potential is a measure of how much tension that leaf is under and how likely it is to pull water up, which is a proxy for how much water stress that grapevine is under. So we're going to use these bags and we're going to put them on the leaves so that we can reduce the impact or the effect of leaf variation on our water potential measurement. When you're doing this measurement, you want to make sure you pick a pretty good leaf for this, and a good leaf is a leaf that is fully expanded. It's no longer going to expand anymore. And you can tell that by the texture of the leaf a little bit. So it should be a little more rough than the younger leaves, which are very, very smooth. In addition to that, you will see that the stem is pretty thick for a grapevine, and it also has a little bit of coloration on it sometimes, depending on the variety. In this case, it's a little bit of red mixed in with the green there. So this is a fully expanded leaf. This is probably one of the better leaves to use, and what we do is we slip the bag on this leaf here, which I will do out of frame. There, the bag's on the leaf. After the bag's on the leaf, we want to seal up the top with that zip seal to make sure that no air and no light are getting into this leaf or into this bag. And you can see that this bag is reflective material. It's made of mylar. This reflective material prevents sunlight from getting into the bag, which limits photosynthesis. And the seal on the bag limits gas exchange because the leaf only has the air that was placed in there when it was put in the bag. So what this does is it limits the amount of respiration and the amount of transpiration and photosynthesis that leaf is doing, so that its water stress potential, or its water potential, more closely is related to the stem that it's attached to, or the cane or shoot. Other aspects of the leaves that you really want to pay attention to are if it's damaged, like this here. We can see that there's a rip in the lobe area on this leaf. That is not going to give us a good reading and could actually change the water potential measurement. So we avoid collecting those leaves or placing bags on those leaves for stem water potential. We also want to make sure that our leaves are roughly the same height or in the same area of each shoot that we're selecting from. So I've been going typically about 5 or 6 nodes up, maybe 7. So this leaf is actually quite a good leaf to select. We also want to make sure that when we're doing this, we are placing these bags on the side of the canopy that does not get morning sun. The sun exposure early in the morning also changes the reading that we're going to get because they're already transpiring, they're already photosynthesizing. And all this together helps limit variation in our results. So we get more consistent numbers that more closely represent the actual water stress of that grapevine. So I'm still setting up these bags for today's measurements, but let's say that we already completed putting the bags on. When would we want to actually take these measurements? The best time to do water potential measurements is midday or around solar noon. And that's because that's the highest evaporative demand that grapevines have during the day. And you get the most representation of how much water they're pulling or how much water they need during that day and in your measurements. So we do these measurements sometime between 11 and 1, 11 a.m. and 1 p.m. in California. That might change based on where you are, but for the West Coast, anytime between 11 a.m. and 1 p.m. is ideal. One question I get a lot as a cooperative extension advisor, not just with water potential measurements, but with a lot of other measurements that we do in the vineyard, like soil testing, nutrient testing, is how many do I need to do per acre? And as farmers, a lot of farmers are used to thinking about applications and management strategies per acre, which is not wrong. However, I think when we're doing these measurements, the goal is to see differences. And whenever a difference occurs in your vineyard, the best thing to do is to take another set of measurements. So that could be a distance in elevation change. It could be a different cultivar. It could be a different rootstock. It could be a change in your soil type or your irrigation design or your water availability. It could be any of those things. And my recommendation is you should do at least 3 samples for every place where there is a significant change in either the grapevines themselves or the environment that they're growing in. So we've put these bags on our ideal leaves, right? Fully expanded leaves that are on the evening side or not the morning sun side of the canopy. And we need to wait for them to equilibrate with the rest of the grapevine before we collect them. How long is that? It depends on the variety, it depends on the climate, but it's a minimum of 10 minutes and you can leave them on much longer, as long as you take those samples or those leaves off that grapevine before that 1 p.m. mark when solar noon or midday is considered over. Okay, so how do we actually take a stem water potential measurement? First, we need to turn on the pressure chamber, and I'll show you how to do that. So let's say we've left the bags on the grapevines for at least 10 minutes. How do we measure stem water potential in grapevines? Well, we'll use this instrument. It's called a pressure chamber or a pressure bomb. And let's open it up, and you can see it's consisting of quite a few parts and pieces and gauges. One of the main aspects of this is the chamber. So this is the chamber. The chamber has a hole to place the grapevine petiole in, and you can tighten it by tightening this black part at the top. The leaf goes in here undamaged, and the petiole sticks out the top, and you would seal it shut, tighten it so that it's airtight, and then you would pressurize it using this dial toward chamber like this. When you do that, nitrogen gas will come from this tank through this hose and then through the chamber past this rate valve, which we don't touch because if we close it all the way it could get damaged, and then into the chamber. And what it's doing is basically using gas to squeeze the water or the liquid out of the leaf. And by doing that, when we start seeing liquid come out of the top of the petiole here, right at that moment where the water starts coming out, or the liquid, we turn it off and take a measurement here. The measurement in the red numbers is our bars, or the amount of pressure it takes to squeeze water out of the grapevine, or another way to think about it is the amount of pressure it takes, force it takes, to match the tension or the pull of the water in that leaf. So typically a water stress grapevine will be somewhere above 12 bars, maybe 13 or 14 depending on variety, but usually never above 20 bars. So the leaf itself would be negative 15 bars, and we're matching it with positive 15 bars of pressure. A bar is an atmosphere, so that's 15 atmospheres of pressure. Grapevines that are 11 bars or less, or in their case it'd be negative 11 bars or greater, are not usually considered water stressed, and most grapevines, unless they were just irrigated, won't be below 5 bars. This gauge over here is to measure how much nitrogen gas is in this tank. Typically, it's gonna be somewhere between 2,000 and 500. We need at least 300 psi of pressure to do a measurement. So when it gets that low, we either have to refill this tank with more nitrogen gas, or we need to replace it with another tank. We use nitrogen gas because it's inert, and it can be pressurized without a risk of catching fire or combusting. And I'll show you how to use this in the field. So here's your pressure chamber. We can see that it is on already. When you turn it on, you're going to turn this valve on the pressure tank or the gas tank, and you'll see that this number goes from 0 to whatever pressure there is. In this case, we only have about 400 psi of pressure, which is enough to show you an example. This dial should be turned off to the off position, not the exhaust or the chamber yet, and this should be turned not all the way to the right, but a little bit to the right, so that when we pressurize this chamber here, it doesn't pressurize too fast. So this is all set up. You need a razor blade, and then we're going to walk to our first leaf where we are going to take a sample. This leaf has been on the grapevine for at least an hour, which is okay. And what we'll need to do is cut it. So we'll hold the bag, and you see where the petiole is, you bend it slightly, and this sharp razor blade should just go right through it. You want to cut it at an angle. You can see that it is at an angle there, so that you can see the liquid coming out a lot easier. Now we're going to take this back over to our pressure chamber. We're going to put the razor blade down first so that we don't hurt ourselves. I have a magnet on my pressure chamber that I put on there. And then we're going to take the leaf out of the bag like so, and we need to do all of this within 15 seconds. So the lid is off, and there is that hole there. So that's where this petiole is going to go, through that hole. And you can see the leaf is in there now. And then we're going to put the leaf in the chamber. I'll set you down for a sec. And when you put the leaf in the chamber, you want to make sure that none of the leaf is above the lip of that lower chamber. And you can see that it is tucked in there. So you're going to press down and turn right. You'll hear it lock. And then this top part, we're going to tighten until there is no gas getting out when we pressurize it, which you will have to adjust most likely if it's your first time doing this. Okay, we're pressurized. The tank is on. This is in the off position, and the leaf is in the chamber, sealed airtight. Now we're going to watch this gauge and the top of this petiole to see when it starts leaking water. So I'm going to turn this on by turning this knob to chamber. And you'll notice when I do that, this valve over here, or this gauge over here, is going to start going up. And hopefully it's not going up too fast. If you do it too quickly, you'll probably overshoot the reading that you actually are supposed to get. So we want it to be about 1 tick mark per second, 1 red tick mark per second. So on, and we can see, yes, it is going at about 1 tick mark per second, a little slower. So now we're going to watch this, and when it starts bleeding juice, we are going to turn it off like that. And you can see here that I'm taking a break. I'm pausing the gas input here to see, is it leaking yet? And it is not. So I'm going to turn it on for another bar or two. See, now we are at 5.5. We're at 6.5. We were at 5 before. I'm going to take another look at it. Not leaking yet. Turn it back on. Turn it off. Take another look. It's all up, and it's starting. It's starting to. So it's hard to see in the video, but you'll notice that the top is a little bit wet on the right side here where my thumb is, and it is leaking. So that is the point at which the pressure matches the tension of the leaf, and we are at about 7 bars. So this is 7 bars, which means it is not water stressed. Most likely they irrigated this vineyard either this morning or last night. But that's our reading. So this is how you do stem water potential. Once it leaks, that's the end of that measurement. And in order to tear this thing down, you want to turn this dial to the exhaust side. It will release only the nitrogen that's stored in the chamber itself, not from the tank. And then we turn it back off. And then we open this. So turn it open. You can unscrew the top while it's on there. And the leaf just stays in there. You can take this. It is done now. And you'll see the chamber is empty still. And then we'll put this back on for storage. Always lock it when you're traveling. It can fall off very easily. This is still in the off position, and now we need to depressurize the lines in the pressure chamber. So we are going to turn off this valve. Now the tank is sealed off, but the lines still have nitrogen in them. And then we're going to go back to chamber, and what's happening here is all the gas in the lines is bleeding out through the hole in the chamber at the top here, which means that it will not be pressurized in any way when we store it for transport. And once you hear it stop and you see that this value is at 0, you're good to go. So always turn it back to the off position so you don't accidentally waste all your nitrogen gas next time you turn it on. And we are done taking that measurement. So that's how you do stem water potential. It's almost the same process if you prefer to do leaf water potential. The only difference is we don't put the leaves in bags ahead of time. The leaf water potential is a little more inaccurate, and we typically don't use it for scientific research, but it is completely usable in a practical day-to-day sense in a vineyard. If you have any questions, please contact me. My email is on the comments on this YouTube video. And yeah, thanks for coming by.